ultra-realistic, hyper-detailed, cinematic, futuristic, and slightly humorous documentary-style video. Imagine an epic story where humanity decides to pull the moon down to Earth using gigantic, futuristic machines. The scene begins with a majestic, wide-angle shot of Earth floating in space, the blue oceans shimmering, clouds swirling in slow motion, and far away, the moon glowing silver like a loyal companion. A deep cinematic narrator voice rises. For billions of years, the moon has circled the Earth at a calm distance of 384,000 kilometers. But what if humanity decided, one day, to pull it down? The camera slowly zooms into the moon as text overlays appear. Mass equals 7.35 times 10. Distance equals 384,400 kilometers. Orbital velocity equals 1 kilometer per second. The idea feels impossible, ridiculous, and dangerous. But in this futuristic imagination, the impossible is attempted. Cut to ultra-futuristic engineering megastructures orbiting around Earth, stretching like glowing metallic rings the size of continents. Colossal space engines radiate with blue fusion plasma, and miles-long tractor beams fire up, locking on to the moon. These aren't ordinary machines. Each one is as big as a mountain, with mechanical arms the size of skyscrapers, glowing reactors pulsing with antimatter energy. Some machines float in Earth orbit. Some are planted on the surface of the moon, drilling giant anchors into lunar rock, embedding superconductive tethers that glow with plasma streams. Cinematic holograms show the math. To pull the moon toward Earth, humanity needs to overcome not just its orbit, but its sheer mass. Required energy equals 1.2 times 10 joules. The narrator compares this with human civilization. Every year, humanity consumes about 6 times 10 joules. To pull the moon, we would need 200 million years of our entire energy production. Unless, of course, we steal the power of stars. The visuals now shift to a Dyson sphere around the sun, a gigantic megastructure capturing every photon of solar energy. Thousands of kilometers of solar panels glitter around the star, beaming unimaginable energy toward Earth in glowing energy conduits. Simultaneously, massive black hole reactors spin in deep space, extracting rotational energy from singularities with glowing accretion disks that look like fiery halos. Futuristic AI cores manage the whole process, calculating gravitational adjustments in real time with holographic projections of Earth and Moon floating in gigantic control chambers. The pulling begins. Tractor beams fire up, wrapping the moon in glowing blue light, slowly dragging it closer. The lunar surface trembles. Glowing fissures appear. Dust rises into space like glowing smoke. On Earth, strange things happen. Tides go wild. Oceans rise into mega tsunamis that crash into cities. Skyscrapers shake. Continents fracture. Volcanoes erupt from gravitational stress. The narrator adds humor. Congratulations, humanity! Your great experiment just broke your planet before the moon even arrives. Cinematic shots show the moon being yanked closer. At first, just a little bigger in the night sky, then larger and larger until it dominates the entire sky, filling the horizon. Its craters are visible with the naked eye, glowing silver in terrifying beauty. Birds panic. People pray. Cities fall into chaos. AI drones film the spectacular sight as oceans slosh across continents like spilled water in a giant bowl. Suddenly, the moon cracks under the pressure, splitting into enormous glowing fragments. Huge mountains of rock float off into space, some pieces falling like meteor showers onto Earth, exploding with the power of thousands of nuclear bombs. The narrator remarks, "One small step for man, one catastrophic apocalypse for mankind." But the pulling continues. Tractor beams roar louder. Engines fire up. Black hole reactors glow brighter. The Dyson sphere transmits solar energy beams across space like golden lightning bolts. The moon now enters Earth's upper atmosphere, glowing red hot from friction. Its edges burning, fragment peeling off, creating a fiery meteor rain. Entire cities below watch the glowing orb filling the entire sky. Larger than any imagination, scarier than any nightmare. A massive impact sequence begins. The moon collides with Earth in ultra-slow motion cinematic detail. A blinding flash fills the sky. Shockwaves ripple through the atmosphere. Oceans vaporize instantly. Mountains melt. Continents crumble. The camera zooms out to space as Earth glows like a fireball, magma covering the surface. The impact releases more energy than 1 trillion nuclear bombs, equivalent to the crust of Earth being completely liquefied. Cut to a holographic comparison scene. One side shows Earth glowing molten red after impact. The other side shows the required energy bar compared to the sun's daily output. The text appears. Energy to pull moon equals more than the sun outputs in several days. The narrator concludes with humor and awe. To pull the moon to Earth, humanity would need more power than the sun itself. So perhaps it's better to leave the moon where it belongs. Quietly circling us, inspiring poems, love songs, and werewolf movies. The cinematic ending softens. Camera pulls back, showing Earth as it is now. Peaceful blue. The moon orbiting calmly in the distance, shining like silver. Background music becomes calm and orchestral. Final text on screen. Some dreams should remain. Imagination. Energy required to pull the moon equals beyond human capability.